thing that is really my job more than anything, beyond giving you the tools I've already given you, is get you used to trying something, even if you're not 100% sure it's going to work. So today I'm grabbing my name cards. I've just got 2 examples that we're going to go through. So, here's the thing about how today is going to work. First off, you should probably have your identity sheets out unless you've got that all memorized. But I'm going to be calling on people for every step. You need to tell me something to do next. Here's the thing. Sometimes that means you're going to see something, and something someone else did is actually going to be like, no, I know how to see it. Their step actually made it harder. You might be telling me to undo a step. Don't just randomly tell me to undo a step unless you have a reason for it. And that means sometimes your step that you choose to take might actually be the harder way to do it, but in the grand scheme of things, it should work out either way. But you have to tell me something. There is no, I don't know, pass, move on. If you are getting stuck, I'll work with you a little bit. I'll help you out. I'm not going to leave you high and dry. But I need you thinking, I need you to work through things and try things. So, going through the name list. Name cards, not list, cards. Leaf, you're starting us off.
Of course.
Yep. If you see something like this, where do you think you should start?
Get rid of the parentheses.
That's what I do. How do you get rid of parentheses when they're like this?
Just like square them.
You cannot square them individually.
Like multiplying by themselves.
You multiply it by itself. So sine plus cosine is now getting multiplied by sine plus cosine. Other side is staying the same. He's not here. Okay, Devin, now what?
You foil it.
Yeah, you gotta foil it out. What am I gonna get when I do that?
That'd be sine squared, sine, cosine, and then cosine, sine, again, and then cosine squared.
He's not here, I can't call him. She's not here, I can't call on her. They are here. CJ. Now what?
Combine the sine, cosine, cosine, sine, cosine, sine.
Good. Got some like terms here. Faith. Thoughts?
On the right side, can we change the secant and cosecants into sines and cosines?
You absolutely can. Now remind me to go back and teach y'all a trick over here, by the way, at the end of this problem. Okay, that becomes 2. Secant is 1 over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Cosecant is 1 over sine. I hope I'm pausing enough to give you guys time to write, by the way. That's why I'm awkwardly pausing a little bit more. I need you to be able to write and then think about it afterwards. Caitlin, now what?
Can you change the sine squared and the cosine squared to 1 on the left side?
Absolutely. Sine squared and cosine squared are getting added. Yeah, they're not right next to one another, but does order matter in addition? No. So that absolutely can become a 1. Right.
Can those cross out or no?
You talking this?
Yeah.
Not exactly. So, just like up here, they couldn't exactly cancel out, but there is a way where some of that is going to cancel out. No, I'm not going to teach you the trick quite yet. But, we got a bunch of fractions and fractions here. What can we do with some of these fractions?
Can you like multiply them?
We got multiply going in between them. We could change them into a single fraction. Let's start there. To multiply fractions, you multiply straight across. This becomes a single fraction. So does the denominator become a single fraction? So now we got some 1 over cosine sines, which still look like they could almost cancel out, but not quite. Leah? Thoughts on where to go next?
Can you divide the fractions yet?
That's what I do. To divide fractions, you multiply by the reciprocal. Now, we have to be careful with this, because this numerator is not currently particularly nice. So we have to make sure that when we do this, that numerator, that entire thing, is getting divided by the fraction that was in the denominator. And to divide fractions, Leo, what do we do? To divide fractions?
Multiply it by the reciprocal.
And the reciprocal of that denominator is cosine theta sine theta. Technically over 1. You don't need the over 1, you don't need the over 1. Some people need the over 1. Isabella?
What if we two cosine theta sine theta plus 1?
We distribute, and we do get 2 cosine theta sine theta plus 1. Now I'm seeing really promising things, but are both sides the exact same? Not quite. So, Lindsay, you get the easiest step of them all. How do I finish off this process? Flip it around. Doesn't matter which order you go in. You just got to get them the same. I can flip around this multiplication. I can flip around the addition. Okay. Now, this is our problem from start to finish. We could have cut out a couple of steps if we knew about a little trick. Goes back to what Bryn asked earlier. Bryn asked if this stuff could just cancel out. And I pointed out that just like here, it couldn't quite cancel out, but we do have the ability to do something slightly different with that side if we would have liked to. If you notice that the denominator of a fraction has the exact same thing in it as part of the numerator, you actually have the ability to split a fraction. It has to be the entire denominator matching part of the numerator, not the other way around. Entire numerator, part of denominator, doesn't work. But we can split this into 2 separate fractions. We could have split this into 2 over secant theta cosecant theta. There's a c in cosecant. Plus secant theta cosecant theta over secant theta cosecant theta. Had we done that, what is dividing by secant? The same as multiplying by? Cosine. What's dividing by cosecant? The same as multiplying by? This could have easily just changed automatically into 2 cosine theta sine theta. And this would have turned into a 1. We would have gone from this step to this step all the way down to what we had here. Now, granted, we would have needed one of these steps still, because one of these steps did the sine squared plus the cosine squared, which gave us the 1. But if you recognize that, it's not a mandatory thing, it's just a little trick you can do with fractions. In the end, did we still get to where we needed to go? Yeah. Okay. We're going to do just one more problem today. Because the goal here is less about the individual problems, more about getting you out of your comfort zone and willing to try something, even if you're not 100% sure where you're going. Okay, 1 minus tangent to the 4th theta is equal to 2 secant squared minus secant to the 4th theta. Lane, thoughts on where we could start? I know, this one's not as obvious on where to start. What are you noticing?
Well, you could change tangent into sine over cosine if you wanted to, or switch either the secants and the cosines.
Correct. We can change things into sines and cosines. I'm actually not going to do that on this one because that's going to make this one a lot more complicated. So, what are some other things that you notice about the problem? Maybe you don't know what to do with it, but what are things you notice? You notice there's a lot of exponents?
Yeah.
What exponent do we typically want? Yeah, we generally want things squared. Would you agree with me that to the 4th power is squared? Squared. Let's do that. This tangent squared is getting squared. Isn't it? Isn't it? Kaylee. Thoughts on what to do next?
Can we break up the right side kind of like we did on the ones you did earlier, where it'd be like, because technically couldn't it be 2x squared plus x, it's the 4th, like if it was all variables.
So if you're thinking about this as variables, yes, this is like 2x squared minus x to the 4th, and you're talking about breaking it down as in like factoring?
Mm-hmm.
Yeah, let's factor out a secant squared. I'd be left with 2 minus secant squared theta. This side I didn't touch. In fact, exactly what we were going to need to do. At least one version of exactly what we were going to need to do. Addie, thoughts on where we can go next with this? Can we use Pythagorean identity over there? Okay, so the Pythagorean identity, where's my blue identity sheet? That has the secants says tangent squared plus 1 is equal to secant. Now, there's a couple of different ways that we can approach this problem, given that information. One way is to manipulate our identity to try to get something close to this. Is not going to be pretty. The other way is I can change the secants into tangents. Now, when I do that, I'm going to have to change them into tangent squareds plus 1s, which means I might need some parentheses involved, but it can definitely work to our favor. So, secant squared, tangent squared plus 1. Since I'm replacing a monomial with a binomial, I'm going to need some parentheses. 2 minus secant squared becomes a tangent squared plus 1. Since I'm changing a monomial into a binomial, which they're not actually monomials and binomials, they're just single terms, double terms, I need some parentheses, though, to make sure that I put all of the multiplication where it belongs. So that didn't become the prettiest thing in the world, but at least it's all tangents now. Grace, thoughts on what we can do now?
Can we distribute?
We can distribute. We should distribute. What do we distribute first?
The 2 to the tangent square theta?
You talking this?
The other way.
Other way? The 2's not getting multiplied by the tangent squared. The negative
Oh, it's
is.
gonna- okay.
So we distribute that first. I've never done this problem this way. I'm curious how it works. I've done this problem like a dozen different ways. This one's new. I like it. Okay. Becomes a little nicer to look at. Gabby, now what? Oh, I didn't give you time to write. Sorry. I'll go ahead and finish writing. Get back to us. Sorry. I didn't do my normal pause. I got excited. Like I said, I've done this problem a lot. This one's neat.
Tangent squared theta plus 1 to the 2 minus tangent theta minus 1.
Yes. Can I combine like terms first?
Yeah,
Okay. I'm gonna combine like terms first.
good idea.
So this becomes a 1 minus tangent squared theta. And then I will follow your advice and distribute. Don't get me wrong. You could have distributed as was. Would have been more turns, and that didn't sound like fun. Okay, tangent squared times 1 is tangent squared. Tangent squared times negative tangent squared is negative tangent to the 4th. 1 times 1 is 1. 1 times negative tangent squared is that. There's only 2 steps left, and I've got 2 names left. It's perfect. Isabella, you don't look like you believe me when I say there's 2 steps left. You're like, I promise. It's not so bad. John, now what? Yeah, we could combine some like terms. Tangent squared and negative tangent squared cancel out. I'm left with negative tangent to the 4th theta plus 1. Last, but certainly not least, now what?
I don't know how to explain the point. You take like the tangent to the
That is one option. The other option is to change that side back to tangent to the fourth. I think that'd be simpler. Because we chose a different method to approach this problem, the first step was unnecessary. Now, in all actuality, I probably should have done two things in this step. I probably should have changed that and then flip-flopped this side at the same time. Hence the reason it could have indeed been two steps, but I didn't make it two steps. Okay, today's exercise was getting you uncomfortable. That was the goal. Getting you uncomfortable enough to make a decision and do something, because I'm not kidding. This section, the biggest thing is making sure you're trying something. Otherwise, rest of class time is work